Hello, in this video, we're going to talk about RESTful services. So anytime we talk about something new, we want to know why we want to talk about topics like this. Well, in the case of RESTful services, I can very simply tell you that they run the internet. So, and that's why we want to study them. So, a little more specifically, really, all of these big companies that that you've ever heard of, like Google, Facebooks, and Amazons, and Twitters, etc., etc. They all run a full suite of RESTful services, and your computer that runs a web browser or the apps on your mobile phones, they all utilize or use these RESTful services that lives in the clouds. And RESTful service together with kind of JSON. If you understand both of these things, we will actually have a pretty good idea of how we can actually use Python to access all of these many the vast amount of resources or information out there that are available on the internet. And so this is kind of a good showcase of what Python can do um, in a real world scenario. So I think it's a good topic to study, and that's what the assignment is going to be about. Well, so now that hopefully I have your interest, let's look at what RESTful services really are. Now, in to use an analogy, now to kind of have our laptop or our machine to do something useful for us, we in Python at least we import some library and then we make some function calls, right? So in this example, we import the math library and we want the math library to calculate a square root for us. Now the resource it utilizes is the CPU that's on our laptop or our machine. So these are local procedural calls. Now, there are lots of useful resources that actually live on the internet out in the cloud. To utilize those online or remote resources, we can also make some calls. Now, those are not local calls. They are remote procedure calls. So we make a call to the internet, so to speak, right? And there is actually a common architecture for making these calls, and it is called REST. Now, what REST stands for is that it stands for Representational State Transfer. If you want more information, you can go to the Wikipedia article. It's a mouthful. It probably doesn't mean a whole lot of things right now, but what we need to know, at least at a high level, is that it's just an architecture. So, and this is the architecture that with a set of guidelines. Okay, so and it's actually fairly general. Okay, and it enables that some all different manners of client-server communications. I'll explain what client-server means in a moment. And so it's general enough that many different implementation can exist within under these guidelines, but it's also kind of specific enough that they are all these different implementations, they are uniform. Okay, so uniformity is very important. I'll explain that in more detail. And they're lightweight and fast and very understandable. So let's actually get to the specifics now. So I said that it's a set of guidelines. So these guidelines, there are actually 6 guidelines. Um, it's a client-server architecture. Statelessness is stateless. It can be cached. It's a layer system. And then there's this call-on-demand and uniform interface. So the things that are most important, at least in my mind, is that client-server architecture, cacheability, and uniform interface. So let's see what each of those guidelines mean, those 3 guidelines. So first, client-server architecture. Okay, so the internet, it connects a ton of devices with a lots of the servers or the cloud, right? That are sitting out there. So these clients, examples of them are kind of, our laptops that's running Chrome on a Windows or Mac, or the apps that are running on our smartphones. So those are client devices. Servers, well, these are big, huge web services that many of us probably use every day. Twitter, Facebook, Instagrams, Google, Amazon. Those are the services. So server and clients. And so the rest, what it provides an architecture and guidelines so that for creating the online services, by again Facebook, Google, etc., so that all of these clients, despite they appear to be different clients, but they can all communicate with these servers in a uniform way. Okay. So the second REST guideline we want to talk about is cacheability. Now, in order to motivate for this topic, let's think of some of the not so pleasant experience what we might have had with the internet, right? Sometimes we go to a particular website, it could take a long time to load for some reason. Maybe a lot of people are going to the same website at the same time, or maybe our internet provider, they are, some of their equipments might go down, let's say, or like cable services go down, or our own Wi-Fi router goes down, right? In those cases, the internet might not even work. Sometimes it's slow, sometimes it goes down, right? Now, however, for all of these client devices, our phone, our laptop, and all that, we want these clients to feel fast whenever possible, right? Even though sometimes the internet communication can be slow. Okay, so how do we do that? Well, so the idea is that many times when we request something from, let's say, Google, we might request the same thing uh, uh, in again and again in a short amount of time. So so instead of just every time we want the same thing and we go out to the internet and try to fetch the same thing over and over, what we might want is once we retrieve that thing, we can keep that thing on these client devices in something called a cache, so that subsequently, if we want the same thing, we don't have to go out and to the internet to fetch it again. I mean, this can improve performance, and sometimes it can even allow us to access data in a completely offline mode. So an example of that would be kind of the Google offline. In Google Maps, there's the offline maps, right? I don't know about you, but whenever I go, hiking in the mountains or something, I usually lose cell services. But but to use the Google Map, then I will, before I go hiking, I'll download the entire map of the area on my phone, so that even without an internet access, my Google Maps still works. So that's another example of a cache of data to kind of either improve performance, well, in this case, it's actually provide service where there is none. Now, the final REST guideline that we want to talk about is this thing called a uniform interface. So what uniform interface means is that if we want to do the same thing, then we want to do it the same way. Okay, and I think I've used this example before, but that is like driving a car. How are we all able to drive cars made by different manufacturers? Well, that's because most cars, we use this combination of a driving wheel with an accelerator pedal as well as a brake, right? So once we learn this interface, then we can drive pretty much any car, right? At least for those automatic transmissions. Now, why is uniform interface good? Well, I hope it's obvious because it really simplifies life, right? So in the case of a car, once you know how to drive one car, we know how to drive all cars. Now for a programmer, it's the same idea, right? Once we learn one interface, they can use other interfaces, okay? And actually, Python is full of examples like that. To think about that, the quite a few of the built-in data types that we've already learned, such as list and tuple and dictionary, right? Whenever we want to get something from a list or tuple or a dictionary, what is the syntax that we use? Well, they all start with square bracket. It ends with a square bracket, right? So in case of list, we give it in the square bracket, we give it the index. Same thing for the tuple. For the dictionary, it's a little different. I mean, we call it the key, but by and large, the idea is really kind of the same, right? This whatever we put in the bracket is a way to get to the item that we want. Now, that is to get an item. How about to set an item? Well, set an item it's very similar across these different types as well. Well, other than tuple, which we cannot set because it's immutable. But anyway, to set an item, at first we have to get to the item, and then we use the assignment operator and give it a new value. Right? Same thing for the dictionary. We get to the item by the key, and then we assign it with the assignment operator with a new value. So this is what I mean by uniform interface. And this is, we just imagine, if all of these kind of use a slightly different syntax. Maybe some of these, instead of using kind of a square bracket, use a curly brace or something else. Then it gets really confusing. But the good thing is they're all uniform. Now, another thing that I want to draw your attention to is that for all operations, there's a set of uniform set of operations, and then they all operate on some data that are in some sort of collections, list, tuple, dictionary, well, etc. Right? These are all collections. Operation data in some collections. So that's actually applies quite similarly to REST itself. So in REST, which operates in a client-server environment, there are very two important concepts as far as interface goes. So one is the resource. So the resource represents the data that is being operated on, and it is identified by this thing called a uniform resource identifier. I'll show you an example of what it looks like. It really looks like a URL, but it's a URI. And the second thing is the method that, or the operations that can be done on the data or the resources. And there are quite a few common ones, such as, well, get. Get is a really common one. That is kind of like, list, get item. And then there's the put, which is kind of a set operation. And it differentiates between an update, which updates an existing value, and a create or a post, which is create a value that doesn't already exist. And then obviously, if you can create something, you can delete something. So for those of you who are familiar with database, these are actually also the database operation, create, update, get, and delete. So this is an example. It's a concrete example. However, it's a kind of a toy example. Now, so what if we want to actually create a web service so that you can take a quiz online, right? So what would the resource be? Well, the resource might be a quiz question. And to uniquely identify a quiz question, and then we might want to start saying, what does the URL looks like? Well, we are at Foothill College, so we'll start with Foothill College, and then the term. Well, this term is a winter, 2019 term, and what the class is. Okay, CS3B, And for in the class, maybe we are talking about quiz number 1, and then the question number 1. Okay. So yeah, so you follow kind of this hierarchical kind of URL like URI. You can kind of uniquely identify a particular quiz on the web. Now, don't try this. It obviously doesn't work. So that's the difference between URI and URL. URL always take you to somewhere. URI is just an identifier. It doesn't necessarily locate the item for you. Okay. Now, okay. So that's the resource. Now, what kind of thing can we do on this resource, on this question? Well, probably there are two things, right? To look at, for a student at least, is to look at the question and then to answer the question, right? So to look at the question, we want to retrieve it or get it. So basically, we can do a get operation on this URI that represents a question. So this is how we can see it. And then maybe if supposedly this is a multiple choice question, then to answer the question, then we can do a post to the question. And then again, because it's a multiple choice question, then maybe we add a little extra another part to the question, that is, we're answering choice A on this question. So that's, again, it's a toy example, but it shows you how it would work. And a set of these, operations and the URIs together, this whole thing can be, it kind of defines what's called an API or an application programming interface, so that, a client programmer can actually write a little web app or that for taking quizzes. Now, even though this is just a toy example, there are real APIs that looks very much like that. So an example that I linked here is the Twitter API. So if you kind of look at it, basically for Twitter, let's say, you can actually get a list of your friends by doing the get operation on the URI, friends./IDs or friends/list and things like that. So, if you like, you can read through the Twitter API. It's very rich, and you can do a lot of things with it. All right, so hopefully at least it gives you an idea what REST is about. So REST, again, they provide guidelines, okay, but it doesn't tell you how exactly to implement these guidelines. But typically there are fairly standard implementation for REST. And so for kind of communication itself, most RESTful use services used HTTP, which is what we're very familiar with it, because that's what the World Wide Web uses for communication. And then for sending data, as we've been kind of saying, JSON is the format to serialize and deserialize data for transmission over or inside HTTP packets. There are alternatives such as XML, but JSON is really the preferred format nowadays. And then also, even REST itself, there are other alternatives, such as you might have heard of SOAP, etc. But REST has kind of really is nowadays the most popular architecture. Okay, so with all that said, I would like to show you an actual example of how it works. So, but I have to apologize. This is not the perfect example that I had in mind. I used to have one that it no longer works, unfortunately. So this is it's kind of show you the idea, but it's not perfect. So this is the kind of New York Times kind of review movie reviews, right? So we can actually search by typing in some name of a movie and retrieve actually the review for that particular movie, or at least the summary. So I am actually going to open up the, the very powerful tool that's built right inside Chrome, and I can show you exactly what kind of traffic that's actually going between the web browser and the server, New York Times server. So I'm going to type in, this is the name of the movie, and you can see a bunch, just a few requests that went out and then come back. And if we click on, I think this is the method that actually went out. Now, the reason I said this is not the perfect example is the request is actually a post request. I was actually expecting it to be a get request, but it's a post. But I guess it's a post because it's a form. But anyway, what I do want to show you is the data, the response that comes back about the movie Rise of Skywalker. So as you can see, this you should recognize that it's a JSON string. So you can copy this JSON string and just look, go to, oh, I already copied it. So you can paste it into one of these JSON viewers, and then you come back to the viewer, and then you can actually kind of see that this JSON is string actually represent the information that is actually presented here for the search result. So the title is, what's the title? The title is Star Wars: The Rise of Skywalker, right? And then you can see maybe the summary, research is futile, blah, where is the summary? The summary is here, right? So this is what I've been kind of saying. JSON is how information is kind of transmitted over the internet, and this is one very kind of solid example of that. That what the New York Times, what the server sends back actually gets displayed in our web browser, which is a client.